6 times x, positive 6x, and positive 6 times negative 6, negative 36. Now, what happens in this particular example? Just say it out.
The 6 cancel.
They cancel because we have a positive and a negative version. So we're left with x squared minus 36. I want you to do the next one. Okay? Give the next one a shot. Yes. But these two problems are going to prove a point, but I need to prove today. So that's why we're doing it.
I hope it's a 2.
Bro, I have brain.
All right, get to it, get to it.
Wait, do you have Apple Watch?
Yes.
Do you have a 3 squares or a 4?
I think a 3, because I got it a while ago. Okay, did we get the same answer?
Yeah.
What happens here? Say it. They cancel again. So we have 4x squared minus 25. What's the pattern that you observe? Yes.
And they're opposite.
Okay. The middle terms are opposites and they cancel each other out. Yes.
Okay, so you know how 7 there's like like let's say 2x plus 5 is enough parentheses.
Yeah.
And then there's an exponent. Could you do it in this case because they're gonna cancel?
They would have to have the exact same sign. So we have to
Right, because that would make sense.
Yeah.
Okay.
And we're going to talk about that here in just a second as well. Okay. Questions on that? All right. So that's going to come back here in a little bit. Does anybody know the perfect squares? What's 1 squared? 1. 2 squared.
4.
3 squared.
9.
25.
36.
49.
Good.
64.
Really
81. Oh, and 100.
Good.
121. 121.
That's right.
144.
How do y'all know this?
I don't know the rest after that.
Yeah, I know.
169. I knew that. 196.
Okay. So those are the perfect squares. You got to bring it together. Keep it ringed in here. Okay. We are going to need these. Okay. You're going to need these. So this is going to be a good reference sheet for you. Okay. Does it make a difference whether a number is positive or negative when we square it?
No.
It doesn't. Like if you go into your calculator and you type in parentheses, -2 squared, you'll get 4. If you do 2 squared, you get 4. Here's why. If we do -2 times -2, that is the same thing as -2 squared. Yes? You with me? So when I do -2 times -2, that's a negative times negative. What's that make? A positive. Okay? Well, so we'll say 2 negatives make a positive. Yeah. That's absolute value.
That's true.
Yeah.
You gotta have the common.
Okay. So this leads us into our second type of factoring. You ready for it?
Wait. Yeah.
It's called the difference of squares. Okay, difference of squares. So I'm going to fill in the box first. You use difference of squares when you are given 2 terms only. So this is, except for GCF, this is one of the only methods that has 2 terms in it. Okay. So keep in mind, you have to have 2 perfect squares. Now, how do we know what a perfect square is? Guess what? We just wrote them down. Right here. Yes? Those are your perfect squares. So it has to have 2 perfect squares in it. Okay? Now, when I have this, Okay, this is like A plus B, A minus B.
Oh,
Okay, that is what your difference of squares will look like. Just bear with me here, we're getting there, okay? That's what it's going to look like. This one does not work. Okay, my point in telling you this is that your difference of squares problem has to have a negative. If it has a positive, it is not a difference of squares problem. You tracking with me? So for it to be a difference of squares, there's two things it has to have, three things it has to have. How many terms? Two terms. Addition or subtraction in the middle?
Subtraction.
Okay? And it has to have what type of number?
Perfect square.
Perfect squares. Okay? So, let's start with number one. What number is in front of n squared? 1. Okay? I want you to look at your numbers. Are both of those perfect squares? 1 and 4?
Yeah.
Yeah, they are. Okay, we just listed on the front, yes? Okay, 1 and 4 are both perfect squares. Do we have subtraction? Yes, we do. Guess what? We're good to go. Okay? Here's how we do difference of squares. Write your two parentheses. Okay, I gave you a reference at the top, which is nice. Okay, you're going to take the square root of both terms. So what's the square root of 1? 1. Okay, so you're going to put that in the first slot. What's the square root of m squared? If I asked you, if I have x squared and I take the square root, right? Because the square and the square root cancel out. So here it's just m. Okay? Then what's the square root of 4? 2. Now, what do you notice about? Yes. Okay? One of them will be addition, one of them will be subtraction. Let's pause really quick. I'm going to go back to the first questions that we did. What do you notice? Same numbers, right? Different signs. So that's why they cancel out. That's your difference of squares problems, okay? All right, here, 49 and 81. Do we have perfect squares there?
Yes.
Yes? Okay, so we're going to go ahead and take our square roots. What's the square root of 49x squared? 7x. Good. What's the square root of 81? 9. So we'll have 7x plus 9, 7x minus 9. What's your question? Yeah, so it doesn't matter. One of them just has to be negative, one has to be positive. Yeah, if you put 7x minus 9, then 7x plus 9, it's fine. Yep. All right, next one.
Can you just continue?
Oh, wait. Do we have perfect squares?
Yes.
Do we have subtraction?
No.
No. What do you think we're going to call this?
None.
Okay, here's the deal. I need you to listen. Okay, here's the deal. If it's positive, you cannot do difference of squares. But you still need to check to see if you can do GCF. Okay, is there a GCF? Okay, so then you can say it's prime. Okay, so if it's not difference of squares, you still need to check for GCF.
Just think, that's all we have to do. Whoever created 5 numbers and all this crap had to do this like 12 hours a day.
Okay, number 4. 16 minus x squared. Do we have perfect squares?
Yes.
Do we have a subtraction problem?
Yes.
Okay. What's the square root of 16?
4.
What's the square root of x squared?
X.
Okay, now there's something I need you to notice here. Did I change the order to put x first?
Yes.
Did I change the order to put x first? No, I did not. Look at my answer. It's number minus x, number plus x. Do not change the order of your problem. Okay.
Oh,
Because what would happen is you would have this. Is that still subtraction? No. You with me? Okay, it has to be subtraction. So don't change the order of your problem.
4 minus x and 4
Plus, yeah.
Oh, so we switch.
Oh, it doesn't matter which way you write it.
Oh, it doesn't matter if the plus is first.
Nope. Yeah, doesn't matter. Okay, square root of x squared is x. Square root of 1, 1. Positive, negative, or negative, positive. Doesn't matter which order you put it in. Okay. How many more do we have here? Okay, I want you to do number 6 on your own. Don't get too far because there's some other things that have to happen, okay?
That was scary. This has been eventful. Been an eventful class. No, you didn't miss anything. We've only know the problem. Oh. How do you that sometimes?
Do we agree? Do we agree?
Yes.
Yeah? We good?
Yeah.
Okay. 3 more together. Here we go. All right, number 7. What I want you to look at here is, do we have perfect squares?
No.
No. Problem number 1. Do we have subtraction?
Yes.
Okay, so that's fine. So, here's what I want you to look at. If you don't have perfect squares, you may be able to get them using GCF. Is there a GCF that goes into 27 and 12?
Yes.
Yes.
3.
3.
Not
6 does not go into 27. Okay, so 27 divided by 3? 9. 12 divided by 3 is 4. Okay, now look at the inside. Do we have perfect squares? Okay, so here's what has to happen. That 3 is still part of your problem. So keep the 3. And now we can do our perfect squares. What's the square root of 9 x squared? Good. And the square root of 4? 2. So you should have 3x plus 2 and 3x minus 2. Okay, number 8. Do we have perfect squares?
No.
No. Do we have subtraction?
No.
Double issue. Okay? So, what I want you to look at first is, can we do GCF?
No.
Yes.
Yeah.
Okay, what can we pull out? 2?
2 so far.
Yep, we can pull out 2. So if we pull out 2, we have 25 plus 49x squared. Okay, is this a difference of squares problem?
What?
Is this a difference of squares problem? No, why? It's addition, right? That didn't really change our issue. We still can't do difference of squares. We can factor it by GCF, but that's it. Okay, sometimes that'll happen. All right, number 9. I guess I'll just keep the color. That one's pretty easy. What are you gonna get? 6 plus x, 6 minus x. Okay, go ahead and do the problems at the bottom. Okay, there's about 4 minutes left. I want you to come to class tomorrow, and we're going to start by going over the quick practice. Okay? We had a jam-packed class today.
We did a lot.
Did a lot.